Today we are going to be looking at a very interesting question in dimensional analysis. If a physical equation is represented by this, you can see A equals to B exponential minus C minus D1 plus D2 divided by E plus F. Which of these statements is false? Okay. Now the first statement, C must be dimensionless. Okay. Now there is something I want us to know. In dimensions, trig functions, trigonometric functions, and exponential functions, they are dimensionless. And what do I mean by trig function? Sine of anything, sine x, sine 30, sine minus 50, sine I over 2, all of them, they are dimensionless. Exponential functions like exponential 2, if you have exponential minus x, now must also be dimensionless. Because exponential functions are dimensionless, then the argument of the exponential or an exponential function is also dimensionless. What do I mean by that? If you look at this, here we have exponential 2. 2 here is the argument of this exponential function. Then 2 is dimensionless. Exponential minus x taken together is the argument. Then minus x must be dimensionless. If you have exponential minus a over b, you have to be very careful with this. Now, minus a over b taken together is the argument, and the whole entity minus a over b must be dimensionless. But that does not necessarily mean that A is dimensionless or B is dimensionless. But this argument taken together must be dimensionless. Okay, so we are going to talk more about that in this video. So C here, if you look at where C is here, this is exponential minus C. Okay, so because it's just C and there's no other letter there, so this argument, or C, which is a part of the argument now, must be dimensionless because exponential functions are always dimensionless. Okay, now the second option, which says that F and D1 plus D2 must have the same dimension. Okay, so we are going to solve this using the principle of homogeneity. Okay, now if you have A to be equal to BD plus C over F minus 1 over T, in algebra we will see that this equation has 4 terms: 1, 2, 3, and 4. It has 4 terms: 1, 2, 3, and this is the last term of this equation. Then according to homogeneity, principle of homogeneity in dimension, all equations must be dimensionally balanced or dimensionally consistent. And what does that mean? It means the dimension of each term must be equal. So that implies that the dimension of this A must be equal to the dimension of BD taken together, and it must be equal to the dimension of C over F taken together, and it must be equal to the dimension of minus 1 over T taken together. Okay, so if you look at the equation, you will see that they say that F and D1 plus D2 must have the same dimension. I don't think this is correct. If you look at this, this is F. This equation has 3 terms: A, then B exponential minus C is the second term. This whole thing, D1 plus D2 divided by E, is the third term, and F is the last term in this equation. So we can say that A has the same dimension as B exponential minus C, and must have the same dimension as this whole thing taken together, and must have the same dimension as F. Okay, but it will be wrong for me to say F and this term minus D1 plus D2 divided by E, they have the same dimension. But that does not mean that F and D1 plus D2 have the same dimension. So the second option is actually false, and this is what we are looking for. The question says that which statement is false. Then option B is what you are going to pick because it is false. Thank you for watching. If you are interested in the full video, you should check the link below. It will lead you to my YouTube channel.